Good morning, guys. Now, my next video presentation is um, about this load line mark and load line location. So, in this case, we're going to use the summer load line. So, the entire voyage should travel within the summer load line mark. So, let's start, guys. The vessel is a mini bulker and was ordered to load full of her mark. Full load full to her mark, meaning it should be loaded fully at a port located in a summer zone. So the loading port is located in a summer zone and he will be loaded to the maximum cargo. And her summer displacement is 7,573 metric tons, corresponds to the saltwater draft of 6.018 meters. So this is the summer drop, and the TPC of the summer drop is 14.57 tons per centimeters, and her light displacement, which is the light shift, is 1,771 metric tons. Remaining cargo on board on departure from loading port as follows. So in her departure and loading port, this is the remaining cargo on board. Fuel 350, DO 69, low oil 7 meters, freshwater 152, ballast nil, and constant is 95. And it says here, throughout her voyage, her drop is limited only by summer load line. So throughout the voyage, the vessel should maintain the summer load line mark. Okay, and this is question is fine. Number one, quantity of cargo to load, the maximum permissible draft if she is floating in water density of 1.008 tons per cubic meter. So meaning, what will be her draft when the vessel floats at 1.008 at loading port? Her draft if she is floating at sea water density of 1.025. So what will be her draft, seawater draft, when he is outside the ocean with a density of 1.025? If she is about to complete loading and floating at a draft of 5.90 meters and water density of 1.008, find the quantity of cargo remaining on board. So when the vessel at port, when loading, when the vessel reaches at a draft of 5.90 meters, what will be the remaining cargo if the vessel floats in a draft density of 1.008? Okay, and this is the solution. Determine the governing zone. See, the governing zone is summer draft because she is floating within the summer zone. Okay, know the draft and displacement of governing zone. So the vessel is in the area of the summer drop. So the summer drop of the vessel or mini bulker is saltwater is 6.018. Will be his departure drop at loading port, and the displacement of this drop is 7573 metric tons, and the TPC is 14.57. So let's investigate. Summer drop, maximum summer drop is 6.018. 6.018, okay? 6.018, let's see this one. Then we go to capacity table. So summer, this is a load line location, and the drop of summer is 6.018, and the displacement of summer drop is this one, 7,573, and the light chip is 1.771. Okay, then we go say here the maximum summer drop is 6.018, forward and up 6.018. Okay, and the TPC is 1457. So we check that one. I just set the table, then we go down. See, the drop is 6.018, TPC is 14.57, and displacement is 7573. It should be 7573. Okay, so we go back and one. Then we go to number 2. Number 2. Number 3. Is that correct? Double check again. Oh, sorry. So that was number 2. So we go to number 3. Number 3. Find the quantity of cargo that can be lifted. So we will add all the remaining cargos on board. So fuel, diesel, LO, freshwater, ballast, and custom. To sum it all, weights on board or remaining on board is 63673. Okay? And the question a while ago was the quantity, how much the quantity of cargo to load, how much quantity of cargo are we going to load, maximum cargo. Okay, so check on that. So with the summer drop or departure drop of salt water of 6.018, the displacement is 7573, and you deduct it with the light ship, which is the light displacement of 1771, and you will get the dead weight, which is 5802. So displacement minus this light ship will be your dead weight of 5802, then you minus the ROB or the weights on board, which is this one, and the maximum cargo to load is 5129 metric tons. So the answer is loadable cargo is 5129 metric tons. So this is the maximum cargo to load with a draft of 6.018 or summer draft. Okay. The next, number 4, find the departure draft of the water density. So remember, when you're loading in the port or loading port, the density on the local port is 1.008. So with the summer drop of 6.018, what will be his drop if your density is 1.008? Okay, so convert this summer drop or saltwater drop to dock water density of 1.008. Okay, so this is the solution, guys. So to find the displacement of when you have a density of 1.008, the formula is the actual drop times your constant of 1.025 over your local density. So your actual drop is 7573, which is the summer drop of salt water or your departure drop times the constant of 1.025 over your local density of 1.008. And the resultant is the new displacement will be 7701 metric tons. This will be this will be the new displacement of your dock water density of 1.008, and the maximum drop of import will be departure import will be 6.016 with a density of when you are floating a density 1.008. So let's check, guys. We go to 7. 7. So let's investigate, guys, by the loading program. So in the loading port, your summer drop or maximum summer drop is 6.018. The port and starboard, so your mean drop will be 6.018 and the density of 1.025. That will be in your loading port the departure draft. But since you are floating in a dock water density of 1.008, what will be your displacement in your departure draft? So when you are floating in a density 1.008, your displacement will be 7701, or drop is 6.05, which is which is this one. So your displacement is 7701 and your departure drop is 6.0106. Okay, I just show you how uh, to prove it by using this loading program. Okay, and number five, we must get the sinkage. Okay, sinkage. So your final drop or your departure drop with a density of 1.008, your departure drop is 6.016, and your present drop when you stop loading uh, at 5.90. So deduct 6.106 minus 5.09, your sinkage will be 0.206, meaning from 5.90, how much would it take to reach 6.106? So it would take 20 centimeters to reach the departure drop of 6.106, your departure drop of the with a density of 1.608. Okay, now from this sinkage, we can now compute the remaining cargo to load, which is the formula is sinkage times TPC times 100. Now you must the TPC you're going to use here should be converted to this dock water density of 1008. Okay, because you this this drop here, departure drop, is within the dock water density of 1.0008. So your TPC should be in line with the density of 1.008. Okay, to find the value of this TPC is this one. So TPC of dock water is TPC equals TPC times your local density times your constant of 1.025. So you this TPC, which is 14.57, is this is the salt water density. So meaning you put here salt water density of 1.57, which is this one, the density of this one, the TPC of this one. Okay, so this one, and times the local density of 1.008 over 1.025 is constant, and the value of TPC of your local density is 1.328. So you put here 1.038, which is the density of 1.008. So to complete the formula, sinkage, which is 0.206, which is this one, sinkage times your TPC is 14.328, which is this one, times 100 constant, and the answer is remaining cargo to load is 295. Okay, 295. So we will prove this by using the program. Okay, and So when we stop loading, it says stop loading at 5.90, 5.90 to get the remaining cargo to load. So 5.90, and you get the mid drop here. Let's say actual drop here is the same at port side, mid port side 5.90, and starboard side is 5.90. Okay, and your sinkage and your final departure drop would be, this is your final departure drop of loading port is 6.106 of the density of 1.008. Okay, 6.106, 6.6, 6106, 6106. So your departure drop is 6.106. Okay, so your sinkage will be 2.026. So 6.016 minus 5.090 is 0.206. Meaning from this mid drop, or when you stop loading, how much more cargo, so how much more centimeters shall we go to reach 6.016? So it takes 20 centimeters from 5.90 to reach 6.106. Okay, now with this sinkage we convert this one to metric tons, okay, to cargo. So to find this value of this sinkage, this is the formula. Formula would be sinkage is sinkage times TPC times 100. That is the formula. Okay, remember. Okay, sinkage to get the remaining cargo to load equals sinkage times TPC times 100. So we go back to the program. So this is the sinkage. How much remaining cargo to load? Okay. Display first. So the problem says sinkage, which is K8, K8. So sinkage multiplied by 100 multiplied by TPC. M3 M3 is 1 TPC. Okay. Sinkage is this one, K8 and 100%. So to get the value of recommended cargo to load is K8, which is the sinkage, times 100 times TPC. What is this TPC here? M3. M3. But remember guys, this is not the value that we are looking for. We are looking for this value. This 14.328, because you converted from the TPC of 14.57, you apply this local density to get this TPC, new TPC of 14.327. So remember this 14.57. This is the departure, the TPC of this departure drop is 14.64. So what we need is 14.32. And what is the what is the what is the cell is M4. So with this formula, we put here M4. So this one, see? Here, M4. So your K8, which is the shrinkage, times 100 times your TPC of 14.328, and the resultant will be 295. So recommended value or cargo to load is 295. Okay. And there's another solution on how to find the remaining cargo. This is another solution by using the displacement. Okay. The solution is when you stop loading in the draft of 5.90, which is the brackish water, the displacement of 5.90 is 7401. Okay. We'll try to check this one. This one. Okay. Put here. $5.90. How much would be that if his density is 1.028? 7526. Okay. We check again. Brackish water. We put this one to we'll convert this one to salt water. Okay. Back again. This 1.1.008. Then we'll put it. How much would that be in salt water? 1.025. 1.025. Okay. So you see, guys, from the local port, when you stop loading, the drop was 5.90 with the density of 1.008. So the displacement for this local dock water is 7401. Okay, which is this one. 7401 of brackish water of 1.08. How much would it be if how much would it be? How much would be the displacement be if it is floating in salt water? So in salt water should be 7278. Okay, so check this one. So from 1.008 density, how much would be in salt water? So we put 1.025. So in salt water, the displacement will be 7278. And this one, salt water will be 7278. Okay? So this is what we're looking for. The departure drop was 6.018 in salt water, which is displacement of 7573, minus your new displacement or present displacement is 7278. You deduct this one and you will have a resultant of 295 metric tons. Okay, I hope it is clear to you. So there are two solutions, guys. From one is the sinkage, and the alternate solution is by getting the density or displacement. So getting the displacement. Okay. So that's it, guys. And here is another here's another solution that I made. Okay, just here. So we got the summer drop displacement here, and TPC is 14.575, and that will be number 2, number 3 remaining cargo board. You add all re-add all the remaining cargoes, then you have a total of 673. So we go to number 4. Number 3, so summer drop is 6.018. The displacement will be 7573 minus your light ship. That will be your dead weight on 5802. Minus your ROB of 673. Your total cargo to load will be 5129. Okay? And number 4, find the departure dock water density. So your actual, the summer density would be with this drop or this density, your departure density of salt water, how much would be in density of 1008. So this one, displacement times 1.025 constant times over 108. Your conversion of the dock water density displacement will be 7701 or 6.106. Okay, and that will be number 4. And number 5, sinkage will be your final drop minus present drop, which is the dock water of 1.008. 6.016 minus 5.09, your sinkage will be 2.06, and the formula for cargo to load will be sinkage times TPC times 100. So your sinkage is 0.026 times density of 14328, which is this one. You convert the salt water to local density of TPC will be 14.328, which is this one, and this 100. You will have a displacement or remaining cargo to load of 295. Okay, and this is the other solution by using the displacement. Okay, so this brackish water of 9.90 metric tons, you convert this one to salt water. So in conversion, this displacement of 7.01 times 1.08 over 1 constant, and you have a salt water displacement of 7278, which is this one. So this salt water displacement which is this one, saltwater displacement, which is this one, and minus your displacement of 72, 78 of saltwater, which is this one. You will have minus this one, and you will have a remaining cargo to load will be 295. Okay, I hope you get the procedures on how this video was presented. I hope you like it, and if you like it, please click the like button, share, and subscribe. Have a good day, gentlemen, and bye. Hi guys, we will now proceed with our discussions or video presentations. Now, since we have already computed our remaining cargo to load, which is 225, now we're going to distribute this amount to holds 1 and 4, meaning we're going to trim the vessel, guys, with remaining cargo of 295. Okay, let's start. Say when loading, we stop at the draft of 5.90. So put here 5.90, and up will be 5.90. That will be forward now. Okay, and since we have taken out the draft forward and up, we'll also take the actual draft of midship port and midship starboard. For example, the draft mid port is 5.90, and our actual mid starboard drop is 5.90. So there's no list, even kill, and there's no trim. Okay, now our final sailing drop at density of 1.008 is 6.106. This will be our final mid drop or departure drop. So we will how to get this recommended cargo to load is by this formula. Remaining cargo to load is sinkage times TPC times 100, then you will get is 295. Okay, so we go back. So here is the formula. K8, which is the sinkage, K and 8 sinkage is 0.026 times 100 is constant times M4. M4 is this one, letter M and row 4. So that will be 14.328, which is this one. So sinkage is 0.026 times the TPC of 14328 times 100. You have a total amount remaining cargo to load is 295. Okay, that's why you get 295 here. Now once you get 295, follow the arrow, then you put here 295. For example, if you put 295, 995, you will see it here when the results will be for mid will be 6.0101, so it's the same, and sinkage should be 0.201, which is the same. Let's say we put here 300, what happens? Recommended cargo to load is 300. So you put here 300, and what will result? The mid drop will almost be the same. and price sinkage will be 2.08. Let's say make a little bit bigger. Let's say 400. And say what will the results if you put 200? The mid drop will be much bigger. See, this is 6.17 and your sinkage is 0.27. So, but the recommended is 295. 295. Here you can see 295. After loading 295, that will be the results of your mid chip drop is 6.10. It's almost the same, and your sinkage is 0.20, which is the same. Okay. Then according to the program, once you have loaded this 295, then you go to trim two holds. You go to trim two holds, which is this one. Here, remaining cargo is 295, and remaining cargo here is 295. Actual cargo to load. Okay. What does it say? Actual cargo to load for trimming. Okay. Then let's say your loading trimming hold is 1 and 4. Okay. Oh, say 4. Okay. Then let's say you have a trim of, you have no list, no trim, put here 0, and what will be recommended cargo to load in number 1, which is 115. 115, put here 115, 5, and number 4 will be 180. See, 180 in hold number 4. And what will be his final drop? Final drop will be forward will be 6.11, and up drop will be 6.11, which is even kill, no list, and the main drop is 1.06, which is this one. Main drop 1.03, 0.6. Put this main drop. Okay, put this main drop. You can put this one if you like. Pulse main drop. Okay. So you have a list of 0 deflection, and your final drop here on the other side of adless shape cargoes will be forward will be 6.10, up it will 6.10, 0 trim, and your main drop will be 1.037, which is this one, zero deflection. This is the reason why I need this mid drop, which is this one. Mid drop is this one, 6.103. Mid drop this one, which is, I'm sorry, this one, 6.10104, 6.1014, which is this one. Okay. For example, you want a trim of 20 centimeters by the stern. So put here 0.20 by the stern. And what will be recommended cargo to load in number 1? Number 1 will be 95. up will be 200. So you put in number 1, 95, and hold number 4 will be 200. Okay, yeah, 4, 295 in number 1. What will be your final drop? Final drop will be forward will be 6 meters, up will be 6.20, and your trim will be 20 centimeters by the stern, and your mid drop will be 1.01, which is this one. Okay, and you still have zero deflection. So we go on the other side and make it a little bigger. And so when you loaded hold number 1, 95, number 4, 200, and the resultant will be forward will be 6 meters and up will be 6.20. You have a trim of 20, and your mean will be 600995 or a zero deflection. So we make this smaller. Okay, that's it, guys. So whichever holds you like to hold for trimming, you can choose hold which you like. Okay, you can put here 2, you can put here 3 if you like. And what will be the recommended cargo? Let's say you want a trim of just 10 centimeters. So recommended for number forward will be say 5 meters, 5 metric tons, 5, and 290 in hold number 3. Hold number 3 is 290. What will be his trim will be 10 centimeters. So forward will be 6.05 and up will be 6.15. 10 centimeters trim, and your main drop will be still you will have a zero deflection, and that will also be the same here. So you have forward drop of 6.05, up drop of 6.15, trim of 0.10, and main drop here, and you still have zero deflection. So that's it, guys. I hope you like this video. If you like the video, please click the like button, share, and subscribe. Thanks for watching.